Hey guys, today we're going to talk about something really important in functions. It's called function notation. So it's all about how we write and use the letters to designate what a function is and how we can input things into a function. So your aim today is that I can use function notation to determine the rule of a function and to find inputs and outputs. Since functions are the rules that cover inputs, typically your x values, and outputs are typically your y values, it makes sense they must have their own notation to indicate what the rule is, what the input is, and what the output is. In the first exercise, your teacher, that's me, will explain how to interpret this notation. So exercise 1 is going to teach you what this notation is and how it works. So let's take a look at A and look at this notation right here. We pronounce this as f of x. That's how you pronounce it. It's not f times x, it's not f parentheses x, it's f of x. Which is another way of saying basically the function of x. So we're saying that the function of x equals 3x plus 7, which is the rule we talked about in the first lesson. I'm just going to get a different color here. So this 3x plus 7 is your function rule. So how does this notation work? Well, remember, a function is all about your inputs and your outputs. So this f parentheses x, this right here, that x is your input. Just like here, input are your x values. So whatever is in the parentheses here is what you're putting into the rule. So if I look at here, f of 2, I'm basically saying, okay, instead of saying 3x plus 7, I'm going to say 3 times 2 plus 7. I'm basically plugging in that 2. I'm gonna say f of 2 equals 6 plus 7, so f of 2 equals 13. Okay, so basically I'm saying when I plug in 2, I get an answer of 13. The second one, f of negative 3, instead of plugging in x, I'm going to replace the x with a negative 3. So I have now 3 times negative 3 plus 7. It's a really fancy way of what we did in lesson 1 where we plugged in an input and got an output. So f of negative 3, 3 times negative 3 is negative 9. And negative 9 plus 7 is a negative 2. Okay? When I'm done, I can say this is the coordinate 2, 13, and I can say this is the coordinate negative 3, negative 2. I have my input here as negative 3, and my output here is negative 2. Input as 2, output as 13. Function is all about input and output, so this notation helps us figure out what we're putting into the function. Okay? If you want to try the next two on your own by playing around with inputs and outputs, please feel free. Okay? If you want to pause and try it by yourself, I'm going to go ahead and work through them. So letter B, g of x equals x minus 6 over 2. So the second one, g of 20, wants me to plug in 20 for x. So instead of an x here, I'm going to say 20 minus 6 over 2. Equals 20 minus 6 is 14, and 14 over 2 equals 7. So g of 20 equals 7. I could write that as the coordinate 20, 7. It's my x value, this is my y. It's my input and my output. I'm going to keep repeating all this so you guys can start to memorize this relationship. Second one, g of 0. I'll use a different color to make it easier. I'm going to plug in 0 now for x, so 0 minus 6 over 2. 0 minus 6 is negative 6, and negative 6 divided by 2 is negative 3. So 0 is my input, and 3 is my output to give me the point 0, negative 3. Okay. Finally, letter C. H of x. Now, I will make a point here that, do you see how this is an H, this is a G, and our first one was an F? That's just basically giving a letter to the function. We're going to call this function G. We're going to call this function H. F, G, and H are the most common. Sometimes you'll see the letter A. It's just telling you a letter of the function. It's giving you a way to talk about the function. It doesn't necessarily mean anything different because they use different letters. So h of x equals square root of 2x plus 1. So I now have h of 4. So I'm going to say 2 times 4 plus 1. 2 times 4 is 8. 8 plus 1 is 9, and the square root of 9 is 3. So my input was a 4, and my output was a 3 to give me the coordinate 4, 3 for that function. It's input and output. And the last one, h of 0, I have the square root of 2 times 0 plus 1. That's going to give me the square root of 0 plus 1. 0 plus 1 is 1, and the square root of 1 is 1. So my input was 0 for this, and my output was a 1. Okay? So let's formally define this function notation. This is really important. So function notation can be very, very confusing, and I know that. I've taught this several years now, and many students tend to think that, well, because it looks like multiplication due to the parentheses. So that's what this is saying right here. This looks like multiplication. When I write f parentheses x, you may think it means f times x. Oops. That is not what this means, right? That's incorrect. Parentheses in this case do not mean multiplication. This notation serves two purposes. Let's go back up here. I'm just reading up here. It serves two purposes. One, to tell us what the rule is. So if I go back here, the rule for like letter A was 3x plus 7. Your rule for B was x minus 6 plus 2, right here. Your rule for C was the square root of 2x plus 1. So function notation tells you the rule. Usually it's an equation. The other purpose it serves is to specify an output for an input, which in easier terms to understand, right here's the second one, specifying an output for an input, it says, hey look, if I have f of x equals x plus 2, and I want to know what the input is at 3, now I can plug in 3 and say, okay, my input at 3 is a 5. So I have an input of 3, an output of 5. So this is a fancy way of saying here's my input, and here is my output, which is what this says up here, right? Whatever we put in for here, we're going to get an output of whatever we simplify here is to our 5. In fact, let me write that out down here. That this 5 is the output. And this would have been our rule. So I've got three things to think about. You've got to think about your input, you need to think about your output, you have to think about your rule. And this f of x equals y is your notation that helps you get there. The Common Core uses this notation a lot. Very, very much. So it's going to become very important that you recognize it and memorize how to learn it in this lesson. Okay? So we're going to do some more. And this lesson is only talking about function notation, this entire lesson. So it's really, really good practice for you guys. So let's take a look at exercise 2. Exercise 2 says, given the function f of x, remember how to say that, not f parentheses x, but f of x, equals x over 3 plus 7, do the following. Let's look at A first. Letter A says, explain what the function rule does to convert an input to an output. Now this uses the word explain. Explain means use English, right? Write something. So what does this rule do? Well, when I plug in something for x, right, there's my input, what's the first thing I do to it? Well, this takes us back to Unit 2. The first thing I do is that I'm going to first, in fact, let me use a different color. So first, divide the input. My pen. Give me a new one. Sorry guys, let me just try this again. So first, divide the input by 3. That's this first part. Then add 7. So this is me explaining what the rule does. First thing I do to the inputs, divide by 3. The second thing I'm going to do is add 7. Letter B says evaluate. We've talked about this word evaluate a long time ago. I think maybe you've forgotten, but evaluate is a fancy way of saying find. Sorry, this pen, I swear. Find the value. See how the word evaluate has the word value in it? So you're looking for the value. So I have two things I have to find, f of 6 and f of negative 9. So I'm going to write this out nicely. F of 6 equals, well, instead of saying x over 3, I'm going to say 6 over 3. I'm plugging in the 6 where x is. I'm putting in the 6. It's my input. I'm going to simplify. 6 divided by 3 is 2. Carry down the 7. And then f of 6 is going to be 2 plus 7, which is 9. Okay, that looks like a G, but it's a 9. That's f of 6. Now let's do f of negative 9. So f of negative 9. Same thing I did for f of 6. I'm just going to plug in negative 9. So I get negative 9 over 3. First thing I do is I divide by 3. Negative 9 divided by 3 is negative 3. Bring down the 7. And negative 3 plus 7 gives me a positive 4. So I'm finding inputs and outputs. If I want to write it, this is a coordinate. If I was graphing this, it would be x would be 6 and y would be 9. Here, x would be negative 9, y would be a, sorry, not a 7, a 4. Okay? Letter C, find the input. So we're trying to find x, for which f of x equals 13. So this is kind of a confusing question. You have to really care what your input and output is. The f of x here is the same thing as saying y. So I want to find x if I know that f of x equals 13. Show the work that leads to your answer. So the first time I'm going to do in this problem, this is not saying plug in 13, because 13 is not x. What is 13? 13 is y. So if I rewrite my function, f of x equals x over 3 plus 7, it's wanting me to find this right here. Find this. This is what we don't know. Do we know what f of x is? Yeah, it's 13. So I'm going to plug in 13 for f of x, and then try and solve this for my x that I don't know. This is a little harder, because I have to plug in and solve and do a few extra steps. But we've learned how to do this. We're going to subtract 7 on both sides. We're trying to x alone. 13 minus 7 is 6 equals x over 3. Multiply both sides by 3 to get rid of that denominator, and I get x equals 18. So the input when f of x is 13 is 18. So if I want to write this as a coordinate, when I put in 18 as my input, I get out a 13 as my output. Okay, this is like my x, and this is like my y. Alright? And finally, letter D says, if g of x equals 2 times f of x minus 1, then what is g of 6? Show the work that leads to your answer. So suddenly now this is saying, look, I'm introducing a new function g of x. I still need to think about my old function f of x, but I'm thinking about another function g of x. So this says that I want to multiply 2 times f of x and then subtract 1. Well, I know my input is 6, so I'm going to say g of 6 is going to equal 2 times, and I'm going to plug in 6 into what now? F of x right here. Well, f of x is way up there, so I'm going to have to use some parentheses because I'm trying to plug this in. Oh, wait, I'm sorry. I'm not going to use parentheses. I'm going to go back to remembering what f of 6 is. Because look, here's f of 6. I already know what happens when I plug in 6. What do I get? I get 9. So when I see this 2 times f of x, this g of 6, in fact here, let me write it out. 2 times f of x minus 1, I know what f of 6 already is. What is f of 6? F of 6 is this 9. We already figured it out. So this is like saying 2 times 9 minus 1. Really tricky problem, but you're just taking this 6 and plugging it into your function. So g of 6 is going to equal 2 times 9, which is 18, and 18 minus 1, which gives me 17. So this new function, g of x, when I plug in 6, I'm going to get a 17 for my answer. Okay? It's okay that we're working with two different functions. We still have that same input of 6, so we can use algebra to figure out our answer. Alright? And please, if this is a place where you're like, I have no idea what she just got done talking about, mark this place in your notes, put a little note saying here, like, put some question marks maybe. I don't know what Ms. Pennington is talking about right here. Maybe this is something I should ask my teacher in class when I come to school tomorrow. Okay? Put this down if this is confusing for you, and any of your teachers would be happy to explain this particular problem. Okay? Or you can email me. Let's take a look at exercise 3. Recall that function rules commonly come in one of three forms. Equations, right? We have the rule as an equation. A graph, which is why I gave you guys coordinates. And also we have tables, which we haven't talked about yet in this lesson. So let's talk about an exercise that uses all of these forms of equations, graphs, and tables. Exercise 3 says boiling water at 212 degrees Fahrenheit is left in a room that's at 65 degrees Fahrenheit and begins to cool. So this is saying there's some boiling water in the room, and we're leaving it alone in the room and seeing it's going to cool off if you leave the hot water out. Temperature readings are taken each hour and are given in the table below. In this scenario, the temperature is a function of the number of hours. So this is saying that hours, this h, what this sentence means is that h is our input and t is our output. When it says function of, whatever comes after it's your input. Okay, so this is like saying, it is like saying x, but I'll write it here. This is your input and this is your output. Alright? So that's all the information. Now let's take a look at what the question's asking. So number 1, letter A says evaluate t of 2 and t of 6. So this is saying t of 2, this is saying where is h equal to 2 and where is h equal to 6. So I'm going to go to my table and look, here's hours at the top, here's 2, and there's my output of 104. So at 2 hours, it is at 104 degrees. T of 6, if I do the same thing for t of 6, I'm going to find 6 is my input, and what's the output? 68. So t of 6 equals 68. Okay? Much easier in a table than trying to solve an equation. Letter B, Letter B, for what value of h is t of h equal to 76? So now this is asking for what value of h is t of h equal to 76. So this is a little bit different. Now instead of looking at my inputs, I have to look at my output. So where is t of h equal to 76? So I'm going to go to t of h, which is right here. I'm going to find 76. There's 76. And what was my hours? 4. So t of 4 equals 76. So 4 hours, h equals 4. Alright? Letter C, between what two consecutive hours will t of h equal 100? So I'm thinking, well, t of h equals 100. That's a lot like this problem here where t of h equals 76. So I'm going to look at my table and is this number 100? Is this 100? Is this 100? Is this 100? Do I see 100 listed in my table at all? No. T of 100 doesn't show up. But the question says between what two consecutive hours? So consecutive means in a row. So what 2 hours will t of h be 100? So will t of h be 100 between here, between 141 and 104? No, because it's going to go down to 104 but not actually go through 100. Will it be 100 between 104 and 85? Yes. It will at some point between 104 and 85, it will hit 100 at some point because it has to cool off. It's going to hit that degree. So I'm going to say, okay, between t of h equaling 104 and t of h equaling 85, it's going to be hitting 100. But this question is asking for hours. So I'm going to find the matching hours. Well, the matching hours is 2 and 3. So I'm going to say between 2 and 3 hours. This question is also asking me to explain how I arrived at my answer, and it's really important that when a question asks this, you really try hard to make a best explanation as you can. Not every explanation is going to be the same. So here's what I'm going to write for this explanation. I'm going to start with because. So here's my answer. Between 2 and 3 hours, because, here's my explanation, because it goes from 104 degrees to 84 degrees, so it will hit 100 degrees at some point in between. I could estimate. I could say maybe, 2.2 hours. Maybe that's an estimate. I don't know, but I know that it's got to hit 100 between those 2 hours to go from 104 to 85. It's got to hit 100 at some point, right? Let's take a look now at our final example with function notation and a graph. So exercise 3 says the function y equals f of x is defined by the graph shown below. It's known as a piecewise linear function. This is important, this term, piecewise, because it's made of straight line segments. So this is not a normal looking graph, right? This isn't just your straight line, it's not a curve. It's got these like chunks of lines. We call this piecewise, okay? You need to memorize that, piecewise, some big chunks of pieces. So now we're going to answer some questions based on this graph. So letter A says evaluate each of the following. So we've got these things in function notation. I'm going to ask you again to remember that f of x, let me write this somewhere else actually. Let me write it down here. F of x equals y. So x is my input and y is my output. And I can create coordinates like this, x comma y. So I would write this somewhere here. This will help you with this graphing situation. So when I look at my first letter A, I know that x is 1. So I'm going to go find out where on my grid x is 1. X is 1 right here. There's x equaling 1, and I'm going to go up, 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 up. And what's y equal? Y equals 4. So x at f of 1, y is going to be 4. Second one, f of 5. Again, f of 5 is my x. I'm going to go over to my x. 1, 2, 3, 4, 5. And I go down, and I get the point 5, negative 2. So f of 5 is negative 2. That's my matching y value. You're basically making coordinates in a very different notation. And this is like the coordinate, 5, negative 2. And this is like the coordinates 1, comma 4. Try the other two on your own. Pause the video and see if you can get the other two on your own. F of negative 3 and f of 0. Alright? Pause. Okay, I hope you got x at negative 3. I'm going to count left 3. 1, 2, 3. Oops, sorry. 1, 2, 3 and go down. So I'm going to go down to here. And that's negative 3. 1, 2, 3, 4. Negative 4. So you should have gotten a negative 4 for your y to get the point negative 3, negative 4. And finally, your last one, f of 0. Well, 0 is right here at the origin, and I'm going to go up because that's where the line is, and I get 0, 2 for my y. Okay? Letter B, solve each of the following for all values of the x that make them true. Solving is a fancy way of also saying find. So when I'm looking at my graph here, this says f of x equals 0. So this is saying y equals 0. So I'm going to go to my graph and look for all the places that y is 0. Well, y is 0 right here. That's where y is 0. Well, if I'm going to, actually let me use a different color. Let me use yellow for this. So where is y equal to 0? Here is y being 0, right here along this line, and I'm going to make a line and circle everywhere it crosses. It crosses here, it hits the line here, and hits the line here. So those three places are my answers here. So that means that x equals negative 1, x equals 1, 2, 3, 4, and x equals 1, 2, 3, 4, 5, 6, 7. So at these three places, f of x equals 0. It's the opposite of what we did in letter A. Letter A, we were given x, we had to find y. In B, we're given y, and we have to find x. I know yellow is a tough color to use. I'm trying to give you guys a visual here. I wish I had different colors here, but I don't, so I'm going to have to repeat a color. Let's repeat the color red. So here, f of x equals 2. So here's where y is 2. That starts right here, where y is 2. And I'm going to see my point. So x hits y at 2 there, and here. So those two places are where f of x equals 2, where y equals 2. And the corresponding x values would be 0 and 1, 2, 3. Okay, so here and here. Alright. And finally, the last question, what is the largest output? Remember, output is a y value. So this is the same thing as saying, well, what's the biggest y value in this graph? So if I go look at my picture, and I go, here's my black line right here. Watch my black line. Where does it get to be the highest? Boom. Right there is the highest y value. And what's the value of that? It's at 4. So the largest is at y equals 4. And we can even write the coordinate, which is 1, 4, and we can call this a maximum. It's a maximum function. And I answered this question at what x value does it hit? The x value is at 1. 1 is the x value. Okay? Please, please, please do the fluency on your own. Don't copy the answer key and ask questions. This is a very crucial lesson to this unit being successful. Please, please, please take your time and really try and master function notation. Okay? Good luck and ask questions.